Hello everyone and welcome to this session on Unified Modeling Language or UML by Intellipaat. The Unified Modeling Language or UML is a language used in the field of software engineering that represent the components of the object-oriented programming concepts. It is the general way to define the whole software architecture or structure. The UML is a tool for specifying software systems, standardized diagram types to help you describe and visually map a software system design and structure. Using UML, it is possible to model just about any kind of application, both specifically and independently of a target platform. In this session, you will learn all about UML from scratch. Now let's begin with the session. But before we begin with the session, please subscribe to our channel and hit the bell icon for more updates from Intellipaat. So let's check the agenda for the session. First we'll be talking about what is UML, then the different types of UML. After that we'll be talking about use case diagram, activity diagram, sequence diagram and communication diagram. Then we'll be moving forward with state machine diagram, timing diagram, class diagram, package diagram and deployment diagram. So that's all with the agenda. Now let's start the session.
Let's take that deep dive into this world of UML. Now, what is a model? Technically, a model, so this is a basic definition. A model is an abstract, informative representation of a system, helping us in analyzing, understanding, communicating, and testing the various aspects of the system and in an easy and inexpensive manner. Now, what does that mean? So now, see, models can be of a lot of types. We are going to focus on models in the software development domain. So there are practical physical models that you might have made in science exhibitions when you were in school. Those kind of models are also models, but we are going to focus on specifically three types of models, which are very much used in the software industry domain. So anything for any system to be built, before you actually build a system, you need to have a basic idea of what you're going to build. To just give you an example, if I want to build a house, the first thing I would do is draw up the layout of that particular house. I will generate models. These days it's all 3D. So I would create 3D models of how the house would look. And then that would go later into construction. The same concept applies in software development as well. So in software development, there are three major models that we talk about. First one is computational models. Now, computational models are something which we probably have used a lot, but we rarely work with computational models, especially those of us who are not in certain fields such as aviation or, so let me elaborate a little bit about what computational models are. I'm pretty sure most of you here love video games. So when you play a video game, which is a simulator, let's say a Microsoft Flight Simulator, or if you play, I'm not talking about a game like Need for Speed because it doesn't simulate anything, but there are certain car simulators where you actually learn to drive using a model. It's a computer generated model where you have to shift the gears in the right way, you have to accelerate the right way. If you're flying a plane, you have to know all the buttons and controls. So these simulators are basically examples of computational models. They are usually very expensive and they are tailored to one specific use case. Then there are analytical models. Now, analytical models are everywhere. If you are a credit card user, you get these annoying phone calls every now and then, right? Like, sir, do you want to increase your phone credit limit? Do you want to take a better credit card? Do you want a personal loan? How do these companies know that they should be called? Most of the times you probably disconnect saying that I don't want them, but they are calling you for a reason, because they are analyzing your expenditure, they are analyzing your spending behavior, and based on that, they are calculating whether this person fits in that aspect of a person requiring a credit card. And that's why you get these calls. So this is one example of an analytical model where you get some data, you analyze the data, and you try to predict a behavior from that particular data. There are so many other analytical models in place as well. Again, not a topic, but it's good for you to know that analytical models primarily deal with data. It's completely data oriented, data based, and a lot of stuff. So probability, statistics, statistical models, all of this is basically analytical models. And the third, and something that's really important for us today, is descriptive models. Now, as the name suggests, these models describe the behavior of whatever we are, building or trying to come up with. So these models give us a miniaturized overview of the process or the system that is trying to be developed. And UML is one of these. It's one of the modeling techniques for which falls under descriptive models. Okay, so now that we understood the basics of models, like what are these different types of models, let's take a closer step. Now, under descriptive models are also classified into two specific domains, or rather areas. One is application models and the other is data models. Now remember, when we were talking about analytical models, I mentioned that it's completely data based. It doesn't mean descriptive models have nothing to do with data. Even descriptive models sometimes are data based and depend on data to come up with a model. Now, let's take a look at what these models are. So there are a lot of models which are object oriented, hierarchical, relational. There is relationship between various entities, network based models. So for all of these different types of models, which we will not go into, we will not go in depth, data is required. They are all dependent and driven by data. On the other side, you have application models. This is where you are actually building models for an application or a system or a behavior of an application. So all of these models are called application models, and there are a lot of techniques that are used to come up with these application models. Now, UML is one of them, but there are many others. There's something called SysML. So SysML is, you can actually call a SysML as a subset of UML. A lot of things that we will learn as part of these two sessions today and also the next weekend, a lot of these model concepts that you would be learning, although they are part of UML, they are also utilized extensively under SysML. Then there is BPMN. Now, what does BPMN stand for? Now, BPMN doesn't, it's a big scary acronym, but it simply means business process modeling. So what we are discussing right now, UML, SysML, they are more focused on the systems, whereas BPMN models focus more on the business processes. So they are models focusing more on the business side of it, and UML and SysML are models which focus more on the system and application side of it. That's the primary difference between these two. Okay, now let's understand what UML is. You have been hearing me out saying UML again and again. What does it stand for? It stands for Unified Modeling Language. It's a modeling language. If I say language, I'm pretty sure you understand it's not a language like English. It's a set of guidelines, set of syntaxes that enable developers to basically create models which are easy to understand in the field of software engineering. This helps us, in better understanding, in the better understanding of the systems, better analysis of the systems. So coming up with the overall design, that is the whole purpose behind it. Now, you might say, who has made this a modeling language? I mean, there has to be some starting point, right? So there is a group called Object Management Group. It's not, oh my God, it's Object Management Group, or simply OMG. This is a group which actually comes up with the standards. What should be the syntax? What should be the guidelines? Which boxes to use? What does an arrow represent? What does a particular diagram mean? So these definitions, these standards are maintained by the Object Management Group. They also, by the way, maintain the standards for SysML and BPMN as well. So it's not that they only focus for UML. It's a you can call it like the mother book of application modeling. So they come up with these guidelines, they maintain it, they do a lot of subsequent releases. I'm not remembering the latest release. I think it's 2.5 version, but that's the latest version, which is still continuing. And they keep upgrading these modeling standards on a standard regular basis. Okay, now let's look at something which is more detailed. Now, we will be only focusing on UML diagrams today. Now, when I say UML diagrams, okay, so now if you look at these different UML diagram types, so it is broadly categorized in two major areas. One is structural diagrams and the other is behavioral diagrams. Now, what do I mean by structural diagrams? Again, let's go back to the same example we discussed before. I'm trying to build a house. Where do I put the base? How many beams should be there, to support the floors of the house? How many pillars should be there to support the whole house? All of these decisions, how many doors do I have? How many windows do I have? They are structural. They're basically necessary for the structural integrity of the house. So decisions like that, if I come up with diagrams to show where I place the beams, where I place the windows, where I place the doors, basically your floor plans. If you're buying a house, you get a bunch of floor plans from these builders and developers. So floor plans are nothing but your structural diagrams for the house. They are essential components required for the structural integrity of the system. So in terms of software, so you need certain diagrams to define the structural integrity of a particular system. And the diagrams which help you do that are called structural diagrams. Behavioral diagrams are slightly different. What are behavioral diagrams? So behavioral diagrams relate more to the use of the system. So let's say I am building a software. How many people would be using it? How many actors are there? So we will take a much closer look at each of these diagrams, but just on a high level, who are all the actors? Who will be using the system? Who will be using the system at what point? How does time impact the use of a system? Is there any to and fro messaging? So a lot of these aspects are related to the behavior of the system. And for that, the diagrams that you need are basically behavioral diagrams. So now let's start with the first diagram of the day. Oh, okay. Before we actually jump into each of these diagrams, there are certain points that you should be remembering, because by now I'm hopeful that you have understood the basic concepts of modeling, why we actually do modeling, and you have also seen the different types of modeling diagrams that are available. Say that, remember, there are three really important points you have to keep in mind. First thing, always be very selective about which model diagram is to be created. 13 diagrams might cause a lot of confusion. So you will have to have that clarity that my use case, let's say there's an X use case. In that X use case, which diagram is the most well suited? That is a decision you will have to take. And that you can take if you have an understanding of each diagram and its uses. Creation, as we just discussed, creation of all model diagrams while creating a software system might be redundant and at times a complete waste of time. The system that you are building might not require a certain set of design diagrams in the first place, and you spending time on them would be basically a waste of time. And also, the other point is there are different roles which are defined in most of the organizations. So a lot of times, maybe many of these diagrams are created, but it's not usually all up to one individual. It's usually there is a separation of work and effort. So you can actually feel comfortable in knowing that a situation where all the diagrams are required probably will not happen to you in any real world scenario. The second aspect, most crucial aspect, is be collaborative about this. See, the whole idea about creating these model diagrams is not to create a PPT and present it to the management. The whole idea is not about, having a documentation somewhere and saying that, okay, we have these diagrams. The whole idea behind it is to communicate the idea of that system, the design ideas to the development team, and also at times various stakeholders. So the whole idea is about communication, and make sure that during this collaboration, you take the inputs of your team, because teams have a lot of inputs, and things you might miss on while coming up with a model might be, might come up during a discussion, and when you are presenting your model. And make sure that you take those inputs, you incorporate them into the model, you refine it, you enhance it. That's the only way a particular, any kind of a model that we come up with gets refined. Nobody starts, perfect with a perfect model. And that's the third set of points. Be smart about it. See, the purpose of these design diagrams is just to communicate ideas and processes and system details. The idea is not about, it's not a work of art. You're not painting the Mona Lisa, right? You don't have to be perfect. You can miss out certain processes. You can miss out your lines might be crooked. That's all perfectly good. Nobody cares about the artistic perfection. However, as I mentioned before, during your collaboration sessions, you get a lot of inputs. You have to ensure there is a continuous refinement that goes on in improving your model, because the first model that you create definitely is not the best model, right? It's you coming up with an idea. But when you collaborate with people, when you bring in a lot more ideas, the model can expand. It can have both vertical and horizontal expansions. And we'll see some of the examples. So that will give you an idea of how refinement of models also works. So that's basically the essence. Make sure you remember these three areas. Be selective which model to be created for which use case. That's the most important one. Be collaborative. Ensure you discuss it with the team, and do not hesitate to incorporate inputs from the team. And number three, don't worry about the artistic perfection of a model. It's not a work of art. Refinement is a continuous process. Okay, let's move to the next set, which is basically tools. Now, we are talking a lot about this modeling stuff, right? But what do we do? What do we use to create a model? Well, the best answer is a pen and paper, or a pencil and a paper. You can actually create awesome models, with pen and papers or on a whiteboard. But these days we're all working from home, so that becomes secondary. You cannot have a whiteboard at your house. So the next best option is a huge list. So I borrowed this list from Wikipedia. Feel free, just type out list of UML applications and you'll get a huge list. In fact, I have actually reduced this list to a certain amount just to save space in the PPT. A lot of them are paid, but a lot of them are also open source and free to use. So it all depends. So if you join an organization where they have a suite of Microsoft applications, you would be probably using Microsoft Visio. However, if you are creating models on your own, like I do a lot of times outside my workspace, I prefer using something called draw.io. There is which is a free online application. Or I'm more comfortable using Glyphy. So I had taken membership of Glyphy. It's a tool. It allows you to create awesome UML diagrams. So the tools don't matter. There are plenty of options. So as you can see, there's a whole list. So if you want something which is open source and free to use, you have those options. If you are in an organization where you have to use a specific application which is licensed, then you have those as well. The diagrams, the structures, they remain the same. The application, it's the only application which is changing. Cool. So now, so the first diagram that we are going to discuss, so remember we saw that slide which had under behavior there were a lot of diagrams, under structure we had a lot of diagrams. So we are now going by each diagram and what it really means, and how that would work out. So the first diagram that we are going to focus on is called the use case diagram. Now, so let's assume that we are all new to it. Let's start by that. What does the name itself infer? Use case diagram. Well, uh, the name itself is obvious. The diagram is talking about a use case. Now, what is a use case when we, in software jargon? It's a diagram where you actually display all the actors. Now, when I say actors, it's not movie actors. I'm pretty sure most of you would know that. So actors in this context can be anybody who is interacting with the system at any given stage. So let's take an example, a real world example. Okay, we have an example or diagram here. So let's discuss this in detail. Let's dissect this a little bit. So this is basically an application for a travel agency, which allows certain people to make bookings, and at end of the day they can get, they can book airline tickets. Basically, that's the goal. So let's put a goal to this use case. The goal is to book airline tickets using an application. That's the goal of this particular application. However, if you look at this diagram, you see there are four people, mentioned here. So what it really means is there are four different sets of actors or groups of people who would be interacting with this system at various stages. Now let's see how that works. So let's start with the first primary user, and that's a customer. So as a customer, I want to book an airline ticket. So I come in, I need to do a booking for the airline ticket, and I can book a tour. If I want to extend it, I just don't want an airline ticket. I also want to book a complete tour package. So I can extend it to a tour package. So that is the first user who is actually getting involved with the system. Now, there can be another set of users as well. It need not always be individual customers who do bookings. You have travel agents who also do bookings, right? So I don't have time. I'm a very rich guy. I have too much money and I don't have enough time. So I delegated this job of booking certain tours to my travel agent. So travel agents should also have an option to book airline tickets, and then they should now they for them. So if you look at this user journey of this customer and this travel agent, there's a slight difference. So for a customer, the journey is simple. One, if he is booking a ticket himself or herself, they book the ticket, and at the max they can extend it to book a complete tour package. However, the moment we bring in the next player, which is travel agents, the scenario expands. Now, if you look at the journey of customer, even that has increased. Look at the customer. So now if you bring in travel agent books the tickets, but travel agent is not booking the ticket for himself or herself. So there has to be an option to deliver the ticket to the actual customer. And once that delivery happens, there has to be a way for the customer to pay to the travel agent as well. End of the day, this probably, when it materializes into a system, would be just one click by customer and one click by agent. But from a system design perspective, a lot of things would happen in the background. And that is what this diagram talks about, how users would be interacting with the system at various stages. Now, we spoke about two actors, travel agent and customer. Journey was simple. But does the journey end there? No. We need to coordinate with the airline company as well, because they are the ones who are flying the planes. You can book a ticket, but without the help of the airline company, you cannot book a ticket without the airline company, right? They are the ones who will tell you how many seats are vacant, which seats are to be booked, so on and so forth. So they become the third actor in this particular system. So airline companies help the airline tickets. They help in reserving a seat, specifically which seat. So a ticket can have a seat number, cannot have a seat number. But if I want to pre-register a specific seat, that option should be available. And I should have an option, whether it's a customer or a travel agent, they should have an option to pay for this airline tickets, which the airline company should access. If that payment is made, the airline company should receive that payment. So they become a third crucial actor in this whole system. Now let's take a look at the last actor in this. Now we mentioned it's a travel agency application, so we have an option called book a tour. Now, whether it's a customer who is asking the travel agent or a travel agent who is making these bookings, uh, if a tour is booked, then the touring company gets also added into this chain of events. So we have customers, we have travel agents, we have airline companies, and we have travel companies which are arranging these tours. And of course, pay for the tour. So pay for the tour and pay for travel agent and pay for airline tickets. These four are common. What are extend and include meaning, as those are given different positions? Okay. So what does extend here or here mean, and what does include here means? So so from a business analyst point of view, I can give you an okay, let me not use business analyst jargon. So here the idea is what is the primary motive of this system? The primary motive of this system is to book an airline ticket. Whoever is making that booking doesn't matter, can be different actors, but the core idea is to book an airline ticket. What extend means is that if the user so desires, he or she should be able to book a tour as well. So that's an added feature. The core feature is booking an airline ticket. Extend means it's adding an extended feature to book a tour as well. However, what does include means? Include is mandatory. It needs to be there for booking a travel airline ticket. So if you look at this, if let's look at the customer journey. So if customer is booking, no, sorry, let's look at the travel agent journey. So if the travel agent is booking a ticket, he is probably sending that to the customer. The travel agent needs to deliver that ticket to the customer. That needs to be there because he's not booking it for himself. Some amount of payment customers should be making to the travel agent. That also should be there. And finally, here, if you look at it, travel agent is not working for free, right? So there is a commission that he'll be getting. So that needs to include travel agent commission. Similarly, if you are paying the travel agent, you have to pay for the airline tickets also. That cannot be excluded. So that payment would have basically separate sections. What it basically means is you have these separate sections. You probably have seen it when you are making any kind of online payments. So your payment structure is broken down, some commission here, some this, some that, and that information is tracked, and the breaking is something you are seeing as a user, but in the backend, money is going to the respective parties as well. So this include here means it needs to be there for your primary activity to be performed successfully. Whereas extend is an addition, which is, it's an optional. Let's call extend as an optional element, which can be utilized, which cannot be utilized. I mean, if the user decides he doesn't want a tour, he just wants to book a airline ticket, he can stop the journey there itself. Whereas if you are paying a travel agent or you are interacting with a travel agent, certain things need to happen. The journey cannot end at pay travel agent. It also needs to separately send a payment to airline tickets. Travel agent needs to get his own commission. So that needs to happen. Hope that is clear. So you get the idea, right? What a use case diagram is. It is basically detailing, it's giving you a graphical overview of all the actors who are involved in this system at various stages, various levels. It's also giving you a clear picture of the various functions that these individual actors need for their interactions to be successful. So if I am a customer, I need to have this option. I am a travel agent, I need to have these 3 options. So it gives you a clear picture what options are needed by these individuals, the group of individuals. So let's call them actors. And most importantly, where is this used? So this is primarily used at the very initial stages of requirements gathering stage. This is the first time when a business analyst is talking to a business, this is the first use case, uh, first diagram that automatically comes out, because that is when you are actually identifying the various actors. You are identifying how these actors would be interacting with the system, what would be the intricacies, what are mandatory requirements, what are optional requirements, so on and so forth. So now I guess this answers one of the questions that was asked before. How do we know when to use a particular diagram? So if you know when, what are the circumstances where a diagram like this is useful, you will know when to use it. And mostly this is used at the initial stages. So
Just a quick info, guys. Intellipaat provides PG certification in business analysis and product management by ENICT Academy MNIT Jaipur. The course link of which is given in the description below. Now, let's continue with the session.
rarely happens that someone comes up with a use case diagram at the end of the software development lifecycle. Very rare. I mean, I haven't seen it happen, at least in real world. But this is something which happens during the requirement gathering stage. So let's move to the next diagram, which is an activity diagram. Now, what is the biggest difference that you see between that is it. So let's move to the next slide, which is the next set of behavioral diagrams. Now, this is an activity diagram. Now, what is the most striking part about this diagram and the previous one that we saw? What is the most striking that you guys think is different between these two diagrams? So this is not a diagram which is defining the complete system or the complete use case or business case. It is only defining a specific workflow. Sorry, not use case, workflow. Now, this workflow can be the workflow for the whole system. This workflow can be a workflow of a particular component of the whole system. It need not be always a flow diagram of the whole system. It can just be one component of the overall system where you need a specific detailed workflow, and you create a workflow there. Decision making, if yes, so it's basically sequence. Anita's point is sequence, but sequence, we will see a few other diagrams. So sequence is not the most essential part here. The idea is it's more of a workflow. Of course, a workflow follows a sequence. So in that sense, it's sequence as well. Decision making can be there, cannot be there. It's not mandatory to always have a decision making. So in this case, in this use case, there is a decision box where you enter a pin, you get an invalid pin, you get something. It can be a simple workflow without a negative result as well, right? So decision boxes, again, to put it in perspective, it's a detailed graphical overview of workflows within a system, individual workflows of components or the overall system. Both are possible, but it has to be a workflow diagram. It doesn't talk about actors. It doesn't talk about how many people will use it, when they will use it, none of it. It just talks about the simple set of steps that need to be followed for the system to work. User comes, inserts the card, enters the pin, wrong pin, block the pin, valid pin, show the display menu. A simple workflow defining the process. Can be of the whole system, can be of an individual component. Now, this type of diagram, when is it most useful? So when do you use this diagram? Now, this diagram can come into picture at any point of time. Now, I am a business analyst, so I would speak from my experience as a business analyst. So for BAs, this diagram comes at various stages. It can come, yes, it can come at the beginning where you are trying to explain the process to the team. or it can come even in the middle of the so your whole system plan is ready, your architectural diagram is ready, everything is set, but suddenly you are making a new change, so there is a change requirement that needs to be implemented. It's the most easy and most efficient way of explaining your changes to the development team. So this is from a BA perspective. Technical architects, programmers, they have their own perspectives and reasonings why they should be using workflow diagrams. But from a BA perspective, the best reasoning is it helps explain the process to the developer at any given stage. And it can come any given point of time. It's not like, you have to create this right at the beginning or the onset. Yes, at the beginning, it is definitely helpful if you can create workflows for every scenario. Uh, Otherwise, even in the middle of your development cycle, you suddenly realize that there is a point which is not really clear, which needs more discussion. You can actually come up with a workflow diagram, present it to the team, and see how easy and short those meetings would be. You talk less, you show the image, people understand it, they straight away go to development. So it's a really important tool in that sense. Okay, moving to the next, sequence tag. Now we are getting a little bit more technical. So any programmers, coders in the house? Basically specific interactions between various, so most of our software development these days is service based, right? We have two primary approaches. Either we build services which interact with each other, giving shape to the final product, or we use the other way where we don't build a complete service with its own API. We have microservices, individual services which interact with another service to give you an end result. So these are the two primary ways most of the software development happens these days. So how do you explain the interactions between a service or between a service with another service, or how do you explain a microservice, how that would be interacting with another microservice? The best way to do that is by sharing sequence diagrams. Now these are always vertical in nature. They are always represented vertically. They are represented with arrows for interaction. So if you look at this particular example, you have, so you define classes, right? So when you're building something, you need to define classes which would perform certain functions. So you have class A, which is object 1, you have class B, which is object 2. Now how would your class A interact with class B? Now that would be basically something, so you have these messaging, so you would probably send a call to the API, or you just, so if it's a microservice, your class A would send a message to class B, and that would ask for certain values. If you get a positive, you do something. If you get a negative, you do something else, or you return back some value, so on and so forth. So this messaging, if you have to display it to the developer, so this is more useful not for the BAs per se, but it is more useful in technical documentation. So as a programmer, as a coder, if you are building a system which has many classes, and I have worked with teams where we have built software where the number of classes goes into hundreds for a particular piece of code, and the technical documentation becomes really vital there, right? Because a developer might leave at any given point of time. What happens if a new person joins in and wants to understand the system? So written documentation takes ages. So this sequence diagram, very helpful for developers, primarily for developers, but also technical architects to define how individual classes are interacting with what is the behavior of interaction between two classes. So there is something called class diagrams as well, but this is primarily about the behavior, the messaging between two classes that are working in tandem, can be part of a service, can be part of a microservice. Let's move to the next diagram. Now, this diagram is used, but so a lot of these diagrams that you're seeing, that you're going to see next, starting from this one, are interconnected or interrelated. So a lot of times, some people prefer using a communication diagram to explain what they are doing. Some people use some other diagram. So these diagrams are very important. So this particular diagram talks specifically about I made a minor correction. This doesn't talk about the messages. It talks about the interactions. It doesn't talk about, it just talks, there should be one message that goes, two messages should go, three messages should go, or you should get a null value return or some return. It doesn't talk about the actual messaging. This diagram actually talks about the actual messaging. So in this particular scenario, what do we have? We have a user who wants to view a contact list. So the messaging that goes to the system is, system will generate or create a contact list for the user. Now, if the user is trying to save a contact, instead of viewing a contact, if the user is trying to save a contact, so the system will give an option. So the system will basically provide the user to save an option. The system will also provide an option to edit, because a user can either save directly by adding a new contact, or can edit an existing contact and then save it. So in that case, the system would also give a save option. So in this case, there is a manager. So, okay, let me put this use case in a much simpler way. So what is happening in this system is, you have a staff member who wants to either visualize or see the contacts in the contact list, or save a contact, add a contact into the contact list. There is a manager who is the next level contact manager. So now this contact manager is not a user. This is the system, which is basically managing these contacts. It's a component of the system. So there's a component of the system which will show the user the contacts. There's a component of the system which will allow the user to edit the contacts. There's a contact manager which manages all the contacts that are present in the system. There is a persistence manager which basically allows users to insert contacts within the system. And then the list of contacts, a database. So this last system is nothing but a database where the contacts are basically stored. So the user, if he or she wants to create a contact, the view contact list service, let's call it a service, it can be a mini microservice as well, or the component, to be fair, a component of the system which works on this gets triggered. It allows the user, or it shows the user the list of the contacts available. If the user wants to edit a contact, the edit contact option gets triggered, which allows the user to save the information that he or she has added. And then it works with the contact manager in tandem, because contact manager is the system component of the system which is managing all the contacts. So if there is any change to a contact, this service also needs to get that messaging saying that, look, I did my part, I edited the contact, now you make sure that it is updated in your database. Persistent manager is basically checking if there is an insertion of a contact, a new contact is added or not. If it is, the database needs to be updated. And if it is just an edit, then it has to be made persistent. So it has to be updated accordingly. So these circles that you are seeing are basically components of the system, and how user action translates into messaging is displayed in this particular diagram. Now, this is not something which most of the BAs would be doing. This is again something which is a primary diagram, or a highly required diagram for a systems architect. So it's your technical architects, it's your systems architects who come up with these diagrams, which basically explains how the various components of an individual system interact with each other and what those messagings would be. Again, it is also used for both services and microservices. Communication diagram is interaction between actors and system component showing messages, right? While sequence diagram is the interaction between components of the system. I would say just add one more word. So I think, so first part is correct, Anita. So communication diagram is interaction between actors and system components showing messages, while sequence diagram is the interaction between components of a system / classes of a system. It can be It can be the same component of a particular system, and within that component itself, how the messaging is working. But the messaging would not be explicit in a sequence diagram. It's just the flow of events, flow of actions, flow of messaging, but not the actual message. So if you look at this previous screen, it doesn't tell you what kind of message is being sent. What is this message one, message two? It simply says some message will go out to the class B to do some operation, so on and so forth. It doesn't talk about what is that message, it doesn't talk about actions and messages. It just talks about how the interaction works between two components of a system. That's it. Sequence diagrams is definitely steps. It's all about representing certain things, right? So a sequence diagram is the guidelines say that a sequence diagram should always be represented vertically. It should show the various flows, but it should not talk too much in detail about what those messages would be or what those message actions would be. Doesn't mean that you cannot, instead of saying message one, you can actually come up with a combination of two as well. So even this is a set of steps, how various components of the systems are working once a user initiates an action. You can actually represent this same very diagram in this format without having a user. So basically, let me give you a better example. So if you look at this particular screen, okay, so in this, what you are seeing is the end-to-end performance of a system. Now, let's say this view contact list service and this contact manager service. I just want to see how these two services are interacting while creating a contact. I just want to see that. I don't care about the other services right now. I don't care about the users. Would this diagram be best suited for that purpose? No. It's still steps. From a diagram perspective, it's still a sequence of steps. So you have certain sequence of steps. It is just that this is a much more magnified view of sequence of steps. And when I want a sequence of steps between individual components, specific components of the system, then I would rather prefer to use this diagram, because this would give more clarity on how those two specific systems are functioning. It will cut out the rest of the chatter. Both are steps. It's just more magnified, more specific to certain components of a system, right? So see, okay, let me put it this way. I think the confusion is because I said both are steps. Sequence diagrams is a steps. Absolutely correct. Let's not jump back to that. You are correct. Sequence diagrams is a set of steps. Correct. Communication diagram is also a sequence of steps. However, it is giving you a much bigger picture. It is basically a high-level view of how various components within a system are functioning. Whereas a sequence diagram is a much more detailed view, showing how, or rather showing the steps between two components. It's a more specific, focused view of steps between two components, whereas communication diagram gives you a complete bigger picture with all the components in place. Okay, so this is the point that I want to reiterate once more. The same representation can be made using a use case diagram. Absolutely right. However, if you have multiple actors, multiple users, this diagram will become complicated. How would you show? So here is a staff member who is, so there is one actor in this use case who is working. So this can be actually tailored and sold as a use case diagram as well. But let's take an example where you had multiple actors. Imagine the connections that the systems would be making within each other. What happens when there is a travel agent here, or there is another actor, there is another service, a lot of crisscrosses. The whole idea of these diagrams is to make understanding simple, right? So to keep it as clean as possible and as easy to understand visually. If you try to cram this with a use case diagram, and if there are many actors, it will become more of a challenge than a help, because then it will become so crisscrossed and so convoluted that explaining that itself will become a challenge. So the idea is you have to figure out which diagram is best suited for that scenario. So if you have only one user, if you have a set of components, limited set of components, you can actually combine use case and communication diagram, because you just have a few set of services, only one user who is going to use them, a simple flow, done. However, if you have more number of users, more number of services, more number of components, in that case, separating it out is the best way to go forward. Okay, so let's discuss the next one. Now, this is called the state machine diagram. Pretty long name. However, as the name suggests, you make this diagram when you have different states in your application. Now, remember, not all applications are state-based. Now, when I say state, I'm not referring to obvious states, but so let's look at this simple example. It's a game. It's a, let's say, a ping pong game. You start a game, or any computer app, game-based application. So you start a game, either you win the game or you lose the game, right? So there are two primary states in this case. If you win the game, if you lose the game, you go to the lost state and game ends. You win the game, even then you get a different set of messaging, probably you get some rewards, and the game ends. So the end result is simple: new game, end game. That's it. But there are different states. There are different states which define different parameters for the user. So if you win, you'll probably get the different set of messages. You'll probably get some goodies. You get some coupons, something like that. If you lose a game, you probably lose money. I mean, you bet some money, you lose that money, so on and so forth. So there are specific states. When there are specific states in a particular system, in that case, it is best advised to use a state diagram. It's easy to explain a flow of a system using a state diagram when the flow of the process flow of the system contains various states. Now, this is a very simple example. Let me give you an example which is slightly different. Okay, delivery tracking. Delivery tracking is a very good example. So you open your Amazon account, you book something. Now it has various stages, right? So package has left your main vendor, then package has left the supplier, then package has arrived in your home state, package has arrived to a location which is nearby to your house, and finally package is on track to delivery. This whole journey can be explained very well if you use a state machine diagram. Okay, next diagram. Now again, see, if you look at some of these diagrams, they are, some are very complex. Just by looking at them, you see that they have a lot of elements to it. Some of them are pretty simplistic. That again is a point. That's actually a decision maker for you. The more complex a diagram looks to you, means it requires a lot of other elements to be incorporated. So for example, a timing diagram. So let's first understand what a timing diagram is. A timing diagram is basically a representation of a particular system where timing plays a very important factor. What do I mean by that? So there are so let's say you have a system which should trigger certain emails at a certain interval of time. So the system behavior is regulated by set timing parameters. Such information, if you want to convey to a user, to a developer or a development team, this diagram is the most helpful. So just to take a look at this. So what is this example that we have here? So this is the same example where you want to send an email to certain users on a systematic way in a at regular intervals of time. So there is a certain time frame allocated, and within that time frame, an email should be triggered. Now, this is completely system diagram. It has no users, no user involvement is there in this particular use case. So what we are seeing is a swim lane approach. So this is something what we call as a swim lane diagram. So where you have these various flows, one after the other, each is basically a stage, can be a component, can be, a swim lane can be used for variety of purposes. You can actually create a use case diagram using a swim lane as well, but that's something different. So for these timing diagrams, swim lanes are usually preferred, but it doesn't mean swim lanes are restricted to timing diagrams. You can use a swim lane for any other diagram as well, as long as it conveys the message in a very simplistic and easy to understand way. So here what we are seeing is, so the idea is to send a, so there are different activities. So the first activity is sending a mail. Then it's about checking some details. Then details are verified. There is a timing gap. Then a creation of an account is to happen. And then there is again idle wait time. So if you look at these individual activities, displaying results, waiting for feedback, accepting a new account details, all of these activities are basically set apart by certain timing parameters. So for example, an email has to be sent at t plus 3 seconds. That is the rule that has been set. Then checking details should always happen after sending an email and t plus 2 seconds. Then no, sorry, checking details should happen always at t plus 2 seconds, and then detailed verification should happen t plus 2 plus t plus 3, that is t plus 5 seconds. So if you look at these time separators, these are telling you or telling the system, so this is not about a user, it's more about how the systems work within. So you have these time bound parameters in which the system needs to take certain actions, or system behavior is regulated by these time parameters. So to show that visually, this type of diagram is most useful for developers and designers when time frame is a focus area. Okay, so let's move to the next item, which is interaction overview diagram. Now, interaction overview diagram, again, is something which you probably would not specifically use in its context, but it is more about interactions between high level components. So it's a combination of the activity diagrams that we saw, the communication diagrams we saw. It's a combination of all of those. So here in this, so it's another way of representation. It's not like you have to use interaction overview diagram only or activity diagram only. As long as the information is conveyed, it's all flexible. Some diagrams are more rigid than others. So this diagram can be used instead of an activity diagram. Especially when you have more components, you want to give a broader view of the components. This can be used in lieu of a communication diagram as well. So for example, a communication diagram was what we had different components of a system, right? High level view. But I don't want the complete high level view. I want just the interactions between three components. One component or two components, maybe a sequence diagram is really best suited. But I am saying I want to see how the system behavior is when four components are involved or three components are involved. So it's slightly higher level, but it is not a complete picture either. It's like two set of systems that are in place, and I want to see how that works. So here, if you see, you have this one major component which has certain further more details inside it, like you have a user, there's an access control system which is checking certain code once the code is entered, and then it takes a decision. Now if the code is okay, it allows the door to be open. So it's basically access control. You enter a code, your door opens. If the code is not okay, it ends up saying that the door cannot be opened. So now you can represent this whole diagram as a workflow diagram as well, because it's a simple set of actions, steps. However, in this view, it's more about the interactions. So user comes, interacts, enters the code, system checks the code, the code then is getting validated. The access control system validates the code. If the code is okay, door is opened. So the focus is more on the actions part of it, the interactions part of it, then the whether it's the user or the other aspects. It's more focused on the actual interactions. But again, as I said again and again, a lot of these can be used interchangeably. As long as the idea of that system design is clear, it's clearly conveyed, it's perfectly all right. So I can make this as a workflow diagram as well. So there's no hard and fast rule that you have to stick to one diagram and one diagram only. So it's actually a combination of a workflow diagram and it's an interaction overview diagram, but you can actually tweak it to look like a workflow diagram. I mean, if you remove these interactions from within, it becomes a workflow diagram. Okay, let us do a actual activity. So see, a lot of these applications, the ones that you saw, a lot of these applications always have certain set of boxes or design tools, and they are almost common in almost all the applications. So you need not worry about the application you are using as long as you are clear with your the kind of diagram that you want to generate. As long as you are clear with that, you can use any of the tools. So for this particular case, let us use a blank page. I'll just give you the look and feel of this particular system. So you just have to name a file. So that's where it will be saved in your local system. Now, this is your blank page. Now you have a lot of these boxes. Now there are two ways to do it. So you have a lot of individual boxes and you have something called UML. So these are pre-loaded libraries that this site provides. So you can use a box from this UML library. So these are more adhered to the OMG that we discussed about. So these boxes are as per OMG guidelines. So you can use these icons, or you can also use these icons, the general icons that are here. But here you have to put in a little of extra effort. You have to make sure that your arrows and the boxes and the flows are, they are more adherent. You need to put in a little bit of extra manual effort to make them look like these. Otherwise, you can use these ready-made boxes, and you can actually create diagrams of your own choice. So let's take one example.
Just a quick info, guys. Intellipaat provides PG certification in Business Analysis and Product Management by ENICT Academy MNIT Jaipur. The course link of it is given in the description below. Now, let's continue with the session.
So this is an example of a sequence diagram. So the idea is to create a sequence diagram. So what is the scenario here? So scenario is, it's a library find system. So you go to a library, you borrow books from libraries. What happens if you don't return a book on time? There is usually a fine, right? So this is a system for the librarian. You are not the user. The person who is borrowing is not the primary user. The primary user here is the librarian. So the librarian checks whether basically inquires about a borrower. Pardon the language here. Inquires about. So a librarian checks about the borrower details in the system, checks for fine, whether a particular borrower is due for a fine or not. Now how does that information get relayed to the librarian? So the librarian gets some kind of UI display which displays the amount of fine that particular borrower has occurred. And once a transaction is complete, so basically then the librarian initiates whatever action he or she has to initiate. So the transaction is now made available, which the users can pay. Once they pay it, the librarian can close the fine ticket. So whatever the open fine that was there, it can be closed. Now remember, the transaction here is not about a payment system. We are not talking about users coming and paying. So the users can come and pay to the librarian in cash. That is not part of the scope of the system. The scope of the system is limited to allowing a librarian to check for a fine, display the amount of fine, initiate something. So yeah, so the idea is it's not about creating a transactional payment gateway or a payment system. It's about displaying the fine amount, enabling or saying that the transaction is in process or something like that, but not the actual transaction, and then closing the fine. That's the whole thing. So let's so this is one diagram I'll do. So let me first go to draw.io. So what is our first use case? So So in this, we have one user, which is librarian, right? So let's pull up an actor. So you just drag and drop. All the systems work almost similarly. So tomorrow, if you are using Visio, it might have some extra features, but most of the things would be common. So any system that enables UML diagrams has the same way of working. So let's say actor is librarian. So I can name it. Okay. Now, what is the first set of action that is happening? So what is the sequence of events? So inquires about the borrower. Now, when the user is inquiring about the borrower and then user is checking for a fine, where will this information be available to the user? This information will be available to the user in the system in the form of a UI. So a UI is basically a front-end system user interface where they will be seeing this information, right? So let's add a UI here. So let's consider, so UI is a part of a system. So let's use a box, a simple box. It's an object. So let's consider it as an object. And let's name it as UI. Okay. Now, what is the first action? So it's an action. So let's find an arrow. Yeah, this is a better arrow. And let's name it as, okay. So the first step in the sequence of events is inquire about a borrower. Sorry. Now, what is happening in the backend of the UI? So librarian inquires about the borrower. How? From the UI. Now the system actually checks for the fine as well, right? And that also is displayed on the same UI. And then the system displays the same thing on the UI. So this check for the fine is happening in the backend, whereas the display is happening on the front end. So how do I display this? So let us think of something which can show both backend and front end. Okay, let me change this box. It's just a box, but it has something on top of it. So let's say this is the UI. Now what I mean to show here is, oh wait, this is a better option. I'll use lines. So there are a couple of actions that are being performed here in the backend, right? So let me just add another box, and that is the action that is check for fine. Now this is happening in the backend. It is not happening on the UI. Fine, right? As I said, if you use these set of icons, it's a little bit of extra hard work. You have to make the connections and everything manually, and then you have to check the alignment, make sure it's correct. Why am I using it? I'm more familiar with it, but if you are starting, I would leave that to you. Like if you start with the direct UML diagram set of diagrams, maybe you will be much faster using that. Okay, ignore. As I told you, it's not art, so it's a first rough set of work. So check for a fine. Now, if there is a fine, then what is the action? So if there is a fine, you display the amount of fine. So we can add a decision box here, make it smaller, then make an arrow, and then you can draw something in case of yes. Well, you don't need to have a decision box, my bad. See, we are going to display in either case whether there's a fine or not a fine. In both cases, it is going to be displayed in the UI only, right? So there is no need to have a decision box in this case. In both cases, it would be displayed to the user. So inquires about the borrower, the UI in the backend, it checks for a fine, it gives back the information on the UI. Now, what is the next set of things? Next is transaction. So basically what we are going to do here is, let us add one more box, which is transaction. Now transaction, as I said, we are not adding a payment gateway or anything, but that is something which can be extended. But for now, we will not consider that. So let us say this is a box which is connecting to this one. Okay. And let's say this is transaction. And Finally, let's add the main boxes first. That will make it faster. And let's say this is our fine, because fine needs to be closed, right? Okay. So let me add some text. Now here, now the transaction can be outside, can be inside in either case. So if it is system-based transaction, check for transaction. Let's say check for transaction. Usually, if it is a system-based transaction, you can add the class name here itself, which is doing that system-based transaction. If it is something, so if it's outside the system, so let's assume in this case, the transaction is happening outside. It's just a flag that the user needs to close. And so this basically gives you about information about the sequence of events. Now remember, couple of things here. Now the boxes can be colored. So those refine, so UML has certain colored boxes. In this case, I'm not able to see the colored boxes. So there are certain standard colors that are used. So that's again refinement. You can actually work with the team, make it more colorful, make it look much more, much more presentable, depending on the audience you're presenting it. If it's a small team that you're presenting, a sketch like this is perfectly okay to explain that, okay, the librarian is inquiring about the borrower, UI is going to check in the backend for the fine, give some output on the same UI display, and there is an option to initiate okay, let me add some more text here that will make it much more clearer. Let's say initiate. Now how this conduction is happening, if we have another use case to add automated transactions, there will be more flows involved, but just to keep a simple use case, simple sequence of events, this is an example of a sequence diagram. Okay, so I want you guys to come up with a use case diagram, because that's the simplest of all. You have two actors, student and a teacher. Now the student wants to check score meaning check the scores of some exams, let's say, check the timetable so that the student is aware of which class comes next. Yeah, test score is basically updated, added. So this is now coming to another actor, which is the teacher. So teachers will add the test scores, update attendance, and update scores. In case there are any changes to the test score, those updates need to be happened. Couple of things, Yogendra. So you will have to specify the actors in the diagram. So if we look at this diagram, we will not be able to identify who is doing what, right? So you can simply edit it. The content is editable. So I'm assuming this is student. So let me make that change. And this is teacher. Okay. Now, yes, check timetable. See, this is use case diagram. So we do not need anything specific to systems here. We don't have to mention that there is a system which is going to take care. A use case diagram will never mention the system components. So this box here would mean that this is a system component which is going to do something, right? So we don't need that in a use case diagram. In a use case diagram, it's all about users, actors, and actions. It has nothing to do with the system components. So I think we can make a slight change here. We can simply remove, okay, we will not be able to remove it here, but the idea is I'll also make a same diagram again. So we will go through that and we can see how that is changed. So student checking timetable, but how is the student going to check the score? Because it's not just for the teachers, right? A student also wants to check his or her score. So there has to be some option for student to check the scores as well. Students will check the scores, students will check timetable. So check timetable should not be part of the it should be a box of its own. That way students, so it's about actors and actions. So check timetable is an action, so it needs to be in a box of its own. Teacher, I think, is mostly correct, except this one, check. So teacher will not need to check score. Teacher will always need to add a score. And you can actually keep it for both, no harm in that, because a teacher might want to check a score of a student at a later date. So that's perfectly all right. Update attendance, yes, for a teacher. update score. Now see, if you look at this flow of things, now this is establishing a flow. Now there is no flow here. We do not, so in use case diagrams, you don't focus on the workflow aspect of it, right? So for that we have a separate diagram. So for we are not talking about any sequence of events here. We are just talking about actors and actions. However, if we look at this diagram, it would point, it would mean to someone who is looking at it that a teacher is updating the attendance, then that information is going into student management system, which is okay. Teacher is checking the score, then teacher is adding the score, then the teacher is updating the score, and that is again going into the student management system. So it doesn't give a clear picture of actions versus actors, but still it's something, it's good effort. You'll have to make sure that you understand that we don't need this box here. This box is the real problem. If we remove this box and these two arrows, we can actually make it much more aligned to a use case diagram. Okay, cool. Now let's move to the next one. Now this is more, it's more combined. So I would say this is something which is giving me a clear picture, but it is not a use case diagram. It's more about, what was the other one? Let me go back to the examples. So it is more of a communication diagram. If you look at this, you have so many components. Similarly, you have made a component. Interface is one component, that's your first box. Then the second box is a system which is checking the test score, which is checking the timetable. And then there is a system which is allowing the update of attendance and updating of scores. So this is more of a valid diagram, but it's more of a communication diagram and not a use case diagram. Okay. So the next use case is about a communication diagram for a hotel reservation system. I am moving to communication diagram example. Okay, there is one point I want to make, and we missed that in our discussion. If you look at this diagram, there are a lot of numberings before every message. 1, 1.1, 2, 2.1. It's nothing but the sequence of steps. So you guys were making a lot of sequence related diagrams before. Now make sure you add that numbering as well. Like in the sequence of things, which action would precede which action. So 1 is step number 1. Once that is initiated, 1.1 needs to happen. Then 2 will happen. If 2 happens, immediately after that, 2.1 needs to happen, so on and so forth. So the primary 1, 2, 3s are the main sequences, and 1.1, 1.2 is nothing but the subsequences. Like if you initiate 1, then 1.1 needs to happen, then 1.2 needs to happen, so on and so forth. It's just a numbering for the sequence of events, because you can see the steps by the diagram, but the numbering tells you which messaging happens when. And this is something we missed, but you can actually include that in your diagrams. So I'll use square boxes, or I can use, I mean, boxes don't really matter. So let me use square boxes to make it easy. So the first component of the system where the messaging would start is what? It's the UI interface, because that is where system comes into the picture for the first time. It is not about the actors. It is not, you can add an actor here just to make it clear that it's the user who is going to do this. So let's say some user, but the idea of this whole diagram is about how messaging would work between various components of the system. So this actor, okay, let it be, it should be user. It can be any actor. We don't know. We haven't specified any actors, right? If you look at the use case, it doesn't specify any set of actors. It can be anybody who wants to make a reservation. So here we have some actor. So the system starts with UI interface. It then moves to hotel chain selection. So let's say it's a component of the system, hotel chain management. Okay. Then we have actual hotel selection. Let's say hotel selection. Now, once that is done, the next step is reservation. Okay. And finally, it's confirmation. So consider them as components of the same system. There are various components which are going to do these actions. Yes, will happen, but we are not showing any of the actions here. We are showing the components and the messaging between those components. So confirmation. So let's say the step starts with user interface. So make reservation. That is the first step, right? So let me just say this is 1.1, or let's say this is 1, make reservation. This is step number 1. That's the first step that is happening on behalf of the system. User will select, okay, sorry, my bad. I added date later on, right? So it's make select date. One is select date. Now, once user adds a date in the UI interface, that date is sent to the hotel management chain. Now, hotel management chain will check availability of hotels in that particular on that particular date. So let's say it's 1.1 check available hotels on say date. Now remember, I am writing this as text. There is a specific syntax to it. Usually it is in coding like make reservation with select select date. It will be s lowercase d cap. So there's a syntax to it. We will not focus on the syntax. We are trying to understand the concept of it. So there's a messaging format. So for now, let's focus on the messaging. So here system will check available hotels on the say date. Then hotel selection happens. Now here there are two things that will happen. One is 1 point, no, this is step 2, my bad. Let me change this. This is step 2. This is 2.1, where we are saying we are making the hotel selection is done. Yeah, we are making the reservation, make reservation. Okay. And then for making a reservation, what do we need? We need to check if there is a room available. So there will be another messaging by this component of the system to this component of the system to check for available rooms. 2.1.1 check rooms. Once rooms are available, the reservation would be complete. Now reservation is done, and then it is just a confirmation. So there is no need for any messaging. It's basically a display. So let's say it can be the same UI, it can redirect to another page. So let's leave it at that. So let's just add a text here, display. Now this display can connect back to UI interface if it's the same UI. If there is a separate page that opens up, then it's, or if a separate email is sent as a confirmation, then there would be other flows here. But for now, let's end here. So if you look at it, it's a very simplistic set of events, and the communications, let me change it. So this is something which is the internal messaging between the system. So the class names, when coders, they build their own class names, they have a specific notation. So that is the notation that I'm trying to use. I'm not a developer, but still this is how most developers would generate their class names. So the first action is select a date. Second action, send that once that date is received in the hotel management, hotel chain management system, it will check for the specific hotel as per that date, and it will send that to that specific hotel. That message would be sent to that specific hotel. Once that specific hotel receives that message, it will check if it has if it needs to make a reservation. It will check if there are any rooms available. It will send a message to see if any room is available. If room is available, it will make the reservation, and that information would be sent as a confirmation. Now this can happen via email. For that, there will be more flows. If it is display, it will be much more simplistic, so on and so forth. I know these concepts. So unless you are a programmer, or unless you are interested into technical architect roles, these diagrams might seem a little bit challenging initially, but once you start looking at many examples that are available, you will find that the concepts are very simple. It's about messaging of two systems. The syntax might vary. You might find one diagram which is using some other syntax here. Someone is writing in text. Someone is using 1.1.1 as a numbering convention. But the end of the day, there are two concepts. One, it's about internal components of the system and the messaging between them. That's number one. And number two is the messaging, the sequence of that messaging. So once this service initiates something, what happens? What would be the messaging to the second service? If the second service initiates a message, what would be the sequence of that message? So on and so forth. Next set of diagrams, which was the structural diagram. So we start with the most basic structural diagram of all, and that is a class diagram. Now, who uses a class diagram? So far, someone actually asked this interesting question last time, that if structural diagrams are so basic in nature and they define the structure of a system, shouldn't we start with a structural diagram? And my answer to that was, as a business analyst, usually business analysts work with the behavioral diagrams more compared to structural diagrams. So that is one fact. Yes, as a business analyst, I do have a personal bias because I am more proficient, or I use behavioral diagrams more in my day-to-day work. Said that, structural diagrams are also that the first diagram which anybody has to come up with for a particular system is a use case diagram, because without knowing a use case, one cannot develop a system. So that's why we took behavioral diagrams first, but structural diagrams play a very crucial role in terms of developing a system and also in terms of explaining the technicalities of a particular system. So the diagram that we are looking at right now is called a class diagram. Now, who uses this diagram? So any of you who is an aspiring developer, programmer, coder, whatever you want to call it, if you want to get down into the trenches and do coding, then this diagram is really important for you, because this diagram actually helps you create your technical documentation. Now, remember, it's not that only business analysts are responsible for documentation. That's, if someone tells you that, then it's a complete myth. In every professional software company in India, abroad, anywhere, documentation is crucial on all levels. Now, yes, we follow Agile. So Agile says minimum documentation, but minimum documentation doesn't mean zero documentation. Every role is responsible for documenting the work they do. Now, as a business analyst, maybe the levels of documentation are slightly higher or more complex or more detailed compared to the documentation done by individual developers. But does it means that it doesn't mean that developers don't have to do any documentation. So developers, when they do their documentation, what is the primary goal of their documentation? The primary goal of a developer doing his documentation is to make sure that whatever code he or she is writing, if he or she goes away or is not working on that project anymore, if someone else comes in, without going through the lines of code, they should be getting a clear picture of what has been developed. That is one of the core aspirations of enabling documentation by developers. That is one of the main reasons why most companies want their developers to do their documentation as well. So yes, programming, coding is primary. That happens. Without it, the documentation cannot happen. But there is a level of documentation that is also required. Now, developers use different types of formats for documenting stuff. They use GitHub pages where they add their comments. There are technical guides. There are technical blog diagrams, so on and so forth. The best way to establish documentation or come up with your own documentation is by using UML diagrams. Reason? It covers everything that you as a developer would want to convey, and it covers it with the least effort, with maximum visualization. So a class diagram is a diagram where where developers can actually show the actual interactions of various classes and the various operations, relationships, and features of those classes. Now we will go one by one. So this is a 3-slide topic. So we will go one by one. So class diagrams are the main building blocks for any object-oriented solution. So most of the programming that happens today is OOP, right? Object-oriented programming. So for any object-oriented programming solution that you are working on, class diagrams are the best UML diagrams there available. Why is that? So a class diagram actually shows you all the classes in a system, the attributes that those classes have, and the various operations of each of these classes, and also the relationships between multiple classes. Now, what do I mean by all of that? So I will not go too deep into it. I'm not a programmer, but I'll talk mostly in terms of the diagrams and how they are useful. So I will not go into entity relationships or how classes are created. Those parts are not scope of this session. But from a UML diagram point of view, how all these things come into picture, we'll take a look at that. Now, these diagrams are also created by developers. They are only created by developers, by the way. BAs, business analysts, don't create class diagrams, at least unless that analyst is also a technical business analyst. So business analysts again have classifications. So you have functional business analysts, you have technical business analysts, you have business systems analysts. So there are various roles and responsibilities. So saying that business analysts don't create it would be a wrong statement. But
Just a quick info, guys. Intellipaat provides PG certification in Business Analysis and Product Management by ENICT Academy MNIT Jaipur. The course link of which is given in the description below. Now, let's continue with the session.
Functional business analysts or business analysts who focus on the business side don't usually work with these diagrams. It's usually the technical solution architects, the developers, or the technical business analysts or system analysts. These are the guys who might have to work with class diagrams. Now, the example that we are seeing, let's dissect that example. Now, what you are seeing is 4 different boxes, and it has certain values. So let's dissect this particular example. Okay, so we'll come back to this example, but let's look at the structure. So if you look at this structure, there is one heading section, there is one box here, and there is another box here. And then there are some interactions which are connecting lines which show the relationships. We will come back to this diagram, but let's first understand the structure of this particular box structure that we have seen. So what does that box structure mean? So this box structure actually describes certain key elements of a class diagram. What are these key elements? So a particular class diagram always has 3 things. One is classifiers. What are classifiers? So classifiers are the entities of the system which are basically defining some function. They are the basic entities which are performing that function. So they are the names of the classes. If you want to simply put, they are the classes themselves. Now, what do these classes do? What are the features they are offering? What is the behavior of these entities? That is defined, or that is known as features of that particular class. And those features are represented in the second column, basically. So the first column, first row is the classifier, which basically tells you the class name. The second row is the feature, the behavior of those entities, and the lines that you see talk about the relationship between various classes. Okay, so if you look at this diagram now what is this class? This class is about a customer. Now, what is this doing for the customer? It is basically processing customer ID. It is processing customer name. It is processing customer address, and it is processing customer phone. When I say processing, it is utilizing that information for certain functions too. So for certain functions to work, it basically needs that information. And the next part is your features. So these are the features. What does it do with that? So it or rather, how do these entities behave? So if you add a customer, so it helps you in adding a customer, it helps you in editing a customer, and it also helps you in deleting a customer. So this class customer deals with customer information. What does it do? It adds customers, it edits customers, it deletes customers. And what are the entities responsible for these three actions or these three behaviors? It is customer ID, customer name, address, phone number. Based on these three values or four values, these three actions can be implemented. And this class is responsible for implementing that functionality. Clear? Now, if you look at this a little bit closely, it also, because it's a technical diagram, it's not a functional diagram. The people who would be looking at this diagram are well versed with syntaxes. It also talks about something else. Now, if you look closely, besides customer ID, it says INT. Beside customer name, it says string. Besides address, it says string. And before phone, it says INT. Now, what does that mean? It simply means that customer ID is a entity. The value of that entity, customer ID is an attribute, and the value of that attribute will be integers. You can only add integers, which is numbers, whole numbers, as customer ID. You cannot add any characters, ABCD, you cannot add as part of customer ID. Customer name, now there can be another name for it as well. Instead of saying string, I can say char. Char is also a very commonly used form for saying characters. You can only use characters, so it can be ABCD. Address, again string of words, so that's the technical terminology. And phone again is integers. Now these are the fields that are required. These are the attributes that are part of this particular class. Based on these attribute values, these three behaviors are induced. And what are the three behaviors? You can add a customer, you can edit a customer, or you can delete a customer. Clear? Yeah, data type. So you can actually say these are data types: integers, strings, char. Then you have another class here. Again, same sequence of things. You have the class name, you have the class attributes. Of course, users will input the class attribute values, or system will gather those values from somewhere. We don't know. It can be some system which is providing you those attribute values, or some user is inputting them. That will be a different thing. I mean, it will be based on the system behavior and where this class comes into picture. But the idea is these are the attributes, and you need these values, attribute values, to be present to perform these two class actions. What are these class actions? Create order, edit order. And how does this relate with this? So we have a line connecting them. So this class relates to, so once customer details are added, edited, or deleted, only then it is, so this class would be only available, the order class will only be available if your customer class is functioning correctly, it has all its values right. Let's take a better example for relationships. So if you see, these lines are denoting the relationships between the classes, not these dotted lines. These dotted lines are just for these boxes. Focus on the green dotted lines or green lines. These are the ones establishing relationships between various classes. Now, if you look at this particular class, interface is also a class, because interface means anything where, it can be a UI interface, it can be a non-UI interface, as long as certain information, that as long as data is input in that place, or you are receiving some information there, it's an interface. It need not always be a UI. So let's say this interface A interacts with class B. So if you look, let's start from here. So you have class, so first class is interface A. So that is where your main inputs come in from. Class B is dependent on class A. So only when class A has the information in its functions, class B will be kicked in. And class C followed by class C. Class D is independent from class C. If you look at this relationship, it has no direct dependency, but class C works with class E, and class E is dependent on class D. So the relationships on how these classes are dependent on each other can be established by the lines. Now, a classifier. So now we talked about the class names, right? We talked about, so these are classifiers. Now, classifiers are also classified into multiple classes. So how are they classified? So if you look at this, diagram, so you have a classifier. Now, a classifier can be a concrete class. Now, what does a concrete class means? A concrete class is the building block. The first basic class that you come up with when you are writing a code is always called a concrete class. Abstract classes are also, so there are different categories. I'll not go into all of them. I'm not an expert on it. So we have something called abstract classes. We have something called active classes. We have something called generic classes. What are generic classes? So when you are building a code, you have one class which is which has common application. So let me give you an example in real world scenario. So I come from a content solutions background. So when, let's say I'm creating you have used grammar software, right? When you go online, you see that if you type something and your grammar is incorrect, some green red squiggly lines come in. Or if you open Microsoft Word, you have these green red lines coming in, which talk about basically whether your content is grammatically correct or incorrect. So for a system which works on, let's say we are working on a system which is correcting your basic grammar. Now, for that system to work, you need to create multiple classes. So one example of it is, I have a problem. Let's say I want to detect incorrect spelling in a particular set of text. Now, how do I do that? Now, I'll have to first identify whether that is a spelling or not. So for that, I need to create a class which identifies a string of text, certain text, and identifies it as pure text. Now, if it has numbers, if it is alphanumeric, or if it has any special characters, it's definitely not text, right? You will not do a spell check there. If I say 2 alpha B, you know for a fact it's not an English word. So you will not consider that as a word in the first place. You will consider it as some kind of abbreviation or some kind of special denomination, special name, but it is not a regular English word. So you will not classify that as a, so you need a class which first identifies whether a particular string of text is a word or not. Now, you do that for a lot of text. So you have another class which identifies whether a particular text is set of words is name or not. So once you identify it's a word, you also need to know what kind of word is it. Is it a name? Is it a place? So you use different logics, machine learning, whatever. So you have a class which identifies whether a particular string of text is a word. You have a class which identifies whether a particular string of text is a name. You have a string of text which you have a class which identifies whether a string of text is a place. Let's take these three examples. Now, once I have these three classes which are working and which have done their functions and identified three different things, I might need one class of, or I need one behavior, which is in case any of these texts starts with a capital letter. Let's say, I'm just giving a hypothetical example. I need that to be identified. Now, it is applicable to all the text identified by these three classes, right? So you have 1, 2, 3, all three are different classes. They are performing their own actions. But I have a need to do some generic action on all these three classes. So I create a generic class whose only function is to ensure, or I write a piece of code as part of a generic class, which whole function would be to find out, interact with all other classes, identify wherein all the it'll identify whether all these are words starting with capital letter or not. That would be the only function of it. Whether it's actually a word or not, it's not its responsibility. It would be the responsibility of the other class. So all these classes working together will tell you which one of them are words, which one of them are names, and whether they start with a capital letter or not. So again, it's an example that I'm giving. It's a very high level example, and this is something which I have worked in systems, but it's a base example. there can be different types of classes. Interface classes are where data input or data is received or consumed. It can be a user interface. It can be a JSON file format being consumed by an API, and take that information is taken in and then sent forward. So again, a lot of you can have more better detailed definitions if you are inclined on it. Inclined on a technical level, you can do that research. You can identify what are classes, how classes function, and take a deep dive into the various classes and classifiers and how these function. But for now, remember, these are different classes, and without these classes, you will not be able to achieve certain behaviors in a particular system. So these are the building blocks. Let's say these are the building blocks of a software. So that's how we define that's one way of defining a classifier. So you have different types of classifiers: interface, enumeration, generic class, active class, concrete class. Concrete class is usually the most basic class that you come up with when you are writing your code. And then we have abstract classes. Okay, is the structure clear? How to define a particular, in terms of UML, how do you define a class diagram? So what are the various elements? So a class diagram will always, a class would be represented in this set, 3 sections. First section defining the name of the class, second defining the features and attributes, and the third defining the actions or the methods of those attributes. Okay, so the next diagram that we are going to take a look at is known as the object diagram. Now, what is an object diagram? So an object diagram is very similar to a class diagram. So in fact, if you look at a class diagram, it's almost same as, this was a class diagram that we looked at, right? So an object diagram is almost same as a class diagram. However, there are subtle differences. Now, the primary purpose of a class diagram, or rather an object diagram, my bad. So just one sec. So the primary objective of, or the primary purpose of a object diagram is to basically show the relationship between objects or classes. So a class diagram also shows you relationships, but the main focus is on the specific classes itself, on the behavior of the classes, what attributes are available, what are the relationships between these entities, so on and so forth. However, an object diagram is one level above a class diagram. It basically depicts the interactions at any given point of time. It's also known as an instance diagram. I'm sorry, I think I misplaced a slide here, right? Sorry for the inconvenience. Okay, so let's jump back on it. So object diagram is very similar to a class diagram. However, the primary purpose of an object diagram is to show the relationship between various objects. So it doesn't go as deep as a class diagram does. It focuses more on the relationship part of it, and not the attributes, values, function, the behavior of those attributes, so on and so forth. So if you look at this diagram, it also talks about the class. It comes up with the class name. It talks about the attributes that that particular class has. But the main focus is on the interactions of that particular class with the other classes. So again, all these diagrams are available. You can use any one of them, but you have to choose who is your audience and what is the purpose, or rather what is the purpose of that particular scenario at which you are presenting this diagram. So if you want to explain how the attributes, entities function, what are the features, what are the and also the relationships, then a class diagram is the best diagram to choose. But if your focus is only to talk about the classes on a high level and focus more on the relationship of class with other classes, then an object diagram is more suitable. Now, the next diagram is even more higher level. So think about it. So you have used Google Earth, right? So think about it like Google Earth. So when you scroll down to the lowest level, you see things on a minute, clear, granular level. So that's your class diagram. One step above it is your object diagram. So you are looking at the interactions between various classes You are looking at the classes themselves, but you're not looking at the classes on a granular level. Now, if I have to take one step even further, so I want to take one step back. So now I come to the component diagram. So this diagram does not talk about any of the classes. It assumes, it shows you a picture on a component level. So if you look at these boxes, they are individual components of a system. This is similar to one of the diagrams that we discussed when it came to behavior. Remember? But the difference here is it is more focused on the system architecture. It is more focused on the various components. It's not focused on the I think it was the other diagram, which was yeah. So it is similar to a communication diagram, but it is not exactly same as a communication diagram. The reason is the more focus here is on the components themselves and not the interactions of the components. Yes, interactions are also present here. Interactions are always present in all the diagrams, because the whole idea of a diagram is to show you the components, the classes, whatever they are, the elements, and how they interact with it. But the main focus here, the major focus here is the components themselves. So if you look at this diagram, so you have this one component called order. So this is one part of a system. It can be a service, it can be a microservice. It's one part of the system which handles multiple functions. Then there is one more part which is called the product, which is handling certain set of functions, dealing with certain set of functions on the product side. Then you have a customer management system. The customer comes in, where the user interface, be it the user interface, be it validations, user security, data security, all of that. So that component dealing with customer management, that's one component. And account management is another component of the system. Now, how do all these components fit together? What is the broad lines of interactions, and where would the interaction happen in terms of, so if there's an interface required? So if you look at this particular diagram, it talks about a interface. So here it is saying this is where you need some kind of an interface. It can be a UI, it can be a backend system which is providing information. Depending on the scenario, you might need it, but the idea is you need some kind of an interface to input details to this particular component. This component gets some information, it then goes to this component, verifies something. So the information about item code is present within the product component. So it's a product component which provides the necessary validations, the necessary information about item codes. Information related to customers is coming from this component. So the order component does not have that information. So it takes that information from the customer component. And where does the customer component take its information from? It takes one from the users probably directly, but there is some kind of a backend database which maintains the user accounts. So if you are a user, you are logging into Facebook. So let's translate this this diagram to something which we are all familiar with. Let's say Facebook is not a good example. Let's take the example of Amazon. So you as a user are a customer for Amazon, right? So when you are going to buy something on Amazon, now Amazon probably has all of these components in the backend. Now, how would these components be working? So you as a customer come in. So you have a customer management screen. You have your user registration, you add your email IDs, phone numbers, so on and so forth. So that is one component which is basically dealing with the customer on the front end. Now, once you've given your details, you give your email, you do your email verification, and everything is done, your account is created. Now your account is part of Amazon. Previously, you were just a customer. It was customer acquisition, if we can call it. Amazon doesn't know you as a customer. It just, for Amazon, you are just anybody who is walking in. Once you register with Amazon, you become a customer of Amazon. You have an account with Amazon. So your account management system kicks in. Now, if you're ordering a product, you as a customer are ordering a product, you will be ordering it from your front end, whatever interface you have. So you order from your front end, it goes to an order management system. So it has another component which is dealing with all the orders, available product is a different component. So it basically tracks your orders, it takes your orders, checks whether that particular order can be fulfilled or not, and if it is, it can be fulfilled, when it can be fulfilled, so on and so forth. And that order management system also interacts with the product management system. Now in Amazon, when you open, you see a huge list of products. If you search, say, for mobile phones, you get a huge list of product catalogs. So that's a different component of the system, which is basically cataloging all these products, keeping them in place, checking which of them are in stock, which of them are out of stock, how many days for delivery for a particular product, so on and so forth. So the order component will not deal with all of that. It will communicate with the product product component, and based on the information received from the product component, it will give you the required results. It will pass on the required results to the customer component, and you will be looking at it from the customer component. So this is the front end facing component. So in this example, and there is also your account, which is there in the back end. So without an account, none of this would be possible. So only if you have an account, you can actually place an order. Or, I mean, well, these days, you don't need an account as well. You can log in as a guest, but even guest is an account, right? So even that falls under the account management component. So this is mostly used, especially when you are working with very complex systems where you have multiple components involved. A simple system, a simple software, like say a login system or a attendance system, might not have that many components compared to a system which is like, let's say, Amazon, which deals with, product management, order management, customer management, account management. So the more complex the system, the better it can be explained using a component diagram, showing the various structural relationships between these various components. It's a very macro level. It's not granular. On a high level, you can get a picture of how each of these components interact with each other. Let's move to the next one. So the next one is a package diagram. Now, what is a package diagram? Well, as the name suggests, it is basically so when we talk about two components interacting, how would these two components interact, right? Like, it's not like one component is going to come and ask, hey, give me this information. So there is some kind of information transfer or information to and fro movement of information, to and fro movement of data, to and fro movement of actual files or data. It can be data packets, it can be actual packages of files. So this diagram is really best suited when you are actually transferring, where you want to show how packages are moving between systems. Now, when I say packages are moving between systems, it's not like an Amazon box moving from one system to another. So let me give you an example based on this diagram. So what are we seeing here? So we have HR, which is one component of the system. Let's say we have accounting, which is one department, and HR sends employee details, and in case there is any change in accounting, it makes those changes, it sends it to accounting. Now accounting, based on the employee details, adds accounts or removes accounts. So if HR hires a new person, accounting will add an account for that new employee into their system. And HR will if HR is firing someone, or someone is leaving the company, then HR will update their records and accounting, and will send it to accounting. Now accounting will also remove a financial account of that person. So if you look at these two systems, they are two independent individual systems. They are not components of the same system. The previous example, they are all components of the same system. So it was this Amazon app which has all these various components in the background. But here you are actually seeing three different systems. So HR has its own HR management system, let's say, and accounting has its own accounts management system. Two individual systems. However, there is some information. They are connected to each other. So when you are showing these different systems, large scale systems, individual systems, and their intricacies, their interactions, and how data or files. So when HR is sending, let's say, the information about employee details, now it can send it based on a message. It can just be a JSON message or some kind of API call. That's one way to do it. In fact, that's the way most of the systems are evolving and have been transforming for the last 5-10 years. Most of the communication happens using APIs these days. But let's say a traditional method is being used. So HR actually sends a CSV file or an Excel file to the accounting department, but not by mail. The system actually sends a physical file to accounting, although that practice is not very prevalent anymore. But let's say, for sake of the example, so that is a package that is being sent to accounting. So it contains certain documents, certain files, certain values, which is being transferred to another system from one system. So HR system might have its own database where it is storing its information, and when accounting needs certain information, it is sending that via packages. It can be just API calls as well, but the core concept is it's about high level systems, multiple high level systems interacting between each other, and dependencies. So for example, if you look at invoice, so in this whole diagram, HR is sending to accounting. Now invoice generation is customer invoice and supplier invoice. It has nothing to do with HR. So if I am a company, I am dealing with customers, I'm dealing with suppliers, it's a completely third actor. Now think about this from a use case diagram. So you have three actors here: HR, accounting, and invoice. But also think that there are three individual independent systems. Accounting has its own system, HR has its own system, and the third party customer supplier interactions, that invoice generation, that's a separate system. How are these three systems integrated or interacting with each other? HR is integrated with accounting for employees. Invoice system is integrated with accounting when it comes to customers and suppliers. So you just get a very high level, macro level view of multiple systems in a large scale environment and their interactions. The next one is called deployment diagram. Now, so far, whatever we have discussed is either about business processes, or it's about individual components or individual classes, but it's all about the software. What about the hardware? Now, this diagram actually tells you about the hardware. It's all good. I mean, software development, mostly the name itself is software development. So you're developing software, but you cannot ignore the hardware component of it. So any software that is developed right at the onset, right during the requirements gathering phase, the technical architects, the solutions architects, they actually do a parallel analysis during the requirement and design phase. And that parallel analysis is about what should be the best hardware suitable for this particular software that is going to be built. Let's say I'm building a software which is going to help, which is going to publish books. So it's a software for publishing books, let's say. Now, if I build a software on, say, my based on the hardware available on my PC, which is 16 GB RAM and 120 GB hard disk, within 2 days or 3 days, the hard disk will be full, and the system will not accept further orders. If I am building something which requires a lot of processing power, my website needs to host, so it's a complex system. It brings in videos from various places and streams them on your browser. It needs some kind of processing power. I'm making a computer game. It needs high quality, high fidelity graphics. So it needs graphics processing power. So if I set it up on, say, a user PC or even a simple server. So nobody sets it up on PCs, although we have done that in the past. In fact, a lot of companies start when they are doing when they are building products which are not yet there on that level where it is deployed in the market. They test it out. So they create something called as a PO. It's called as a POC, or a proof of concept. So most proof of concepts are created and built on environments which are very small with low specifications, sometimes even individual PCs and laptops. But then again, that's a proof of concept. So when you are actually building a product, you need to account for the traffic that it might encounter. You might have to take into account bandwidth issues, graphics processing, the core processing as well. Like, I mean, certain, so you build, say, 20,000, 30,000 lines of code. To process that code and to ensure a particular functionality is being executed, you need a lot of processing power. And you need to ensure that your hardware actually supports your software. Now, this diagram gives you that idea. It basically visualizes the kind of hardware you would need to support your software. So if you look at this particular diagram, so you need a web server. So you have three basic hardware requirements for this particular application. So it's a deployment diagram for vehicle registration system. So you are registering, you're opening a website, you are registering you bought a car, so you're registering your car with the system. Now, what would be the main hardware requirements? So you need a web server to host that web service, the front end, the UI, where the users would interact. So you need a web server for it. You need an application server wherein all your applications would be installed. Like, for example, what is the vehicle type, what is the what all documentation you have for that vehicle, who is the owner of the vehicle. So all this information, the validating that information, a lot of processes might be involved. So all of this set of applications need to be installed somewhere, right? So that is your application server. And then you need a database server as well. So you need to store some of this information, right? So you need databases for it. So that becomes your database server. And you also have a mainframe computer for this particular, all these systems to be integrated together. You need a mainframe computer to have a comprehensive system. So how would you depict that hardware and combination of hardware and software? You would use a deployment diagram. So this is usually used if all, so these days again, deployment diagrams are there, they are used. It depends on the type of product you're working on. So only and only if you have multiple, you know, hardware requirements, you need a deployment diagram. But these days, most of the things happen on cloud. So these diagrams are transforming. So these days you don't have a physical application server or physical database server. You don't have these things anymore. Everything is on cloud. So your databases are on cloud, your application servers are on cloud, your web servers are anyways on cloud. So all of the things have moved to cloud. So these diagrams, the way these diagrams are used, they have slightly been modified, but they are still relevant, because even if they are on cloud, they are talking about hardware. So they are represented. So the terminology is different. Maybe you will not say an application server, you will say Amazon AWS or cloud-based something, something, something. And database server, you will say something, something. But everything would be cloud-based, but still you would need certain hardware specs for each of your software applications. And these diagrams are still relevant in that sense. Any questions? Okay, now let's move to the last type of diagram. Now this is called a profile diagram. Now this is one of the latest diagrams that UML 2.5 has come up with. So this is basically it's basically used to describe lightweight extension mechanisms. Now what are they? So for example, you have a particular class. So it's not about macro level, it's about, again, individual class level requirements. But even say, for example, you build a class, you build a code which has certain functionalities, you have a class which has tagged values, attributes, so on and so forth, and you want to describe the requirements for the functioning of that particular class. So it's a let me put it this way. So when we took a look at this particular diagram, this was about various hardware and software for a on a macro level. Multiple your software solution is deployed across multiple systems, and how would you present that to a user? Now, this is shredding that all off. We are only talking about one functionality, one application, and its requirements. So it would probably be, let's take an example. You build one piece of code which does something called X. It requires application server. It requires certain bit of RAM. It has certain functionalities that it would do. How would you represent that? So it's again the same diagram, but on a micro level, very micro level, on a class level. Again, I have not used this diagram ever. It's one of the new diagrams that UML 2.5 has come up with, probably in 2016, 2018, I don't remember. And I've not seen this diagram being extensively used in the products or projects I have worked with. But again, it's a very technical diagram, so probably that would be the reason. Technical architects and programmers would be more comfortable using such kind of diagrams. Okay, so next step is again an activity. So then we have another class which is web server. Again, here the attribute is name, which uses characters only. It uses, or rather, its behavior is it sends out process request, it shows a page, it converts a data, it also makes a request for content with application. And the third class is application. Again, the attribute used is name. Using that information, it retrieves data, it processes data, it converts data and makes request for content with database. So database is our next class. So database has again name, it uses characters as input, and it returns the data. It's basically the storage. Okay, let's take a quick look diagram. So if you are close to this, then you have grasped the concept perfectly. So the placement of these boxes is okay. It can be in a different order. The idea is you have your classes specified, you have your characters, your attributes and their entities, which is the values clearly mentioned, and you have the functionalities. So user should also request for a content. Remember, user is requesting for the content, and make request for content with application is the web server which would be doing it. And make request for content from database is the application server or application class which would be doing with the database. So this is basically the high level of class diagrams. I would still recommend. So let's talk about what I want you to do next. So there was one more activity. So I want you guys to go through the Unified Modeling Language Specifications 2.5. So you just Google that, you'll find tons and tons of links. There are so many blogs, there are so many sites which talk about these specifications. So which arrows to use and in which context, which boxes to use and in which context, what is this, which circle is to be used in which context, that is something you will get if you go through these three documentation. So the first two, the first one is basically the actual language specifications released by OMG on a regular basis. The second one is a book, UML Distill, or I think there are web pages available for it as well. It's by Martin Fowler, who has simplified the explanations of UML in a very easy to understand manner with tons and tons of examples. And the third one is something which I have referred extensively for this particular session. It's a blog by Creately. They provide tons and tons of templates. So Creately is basically a template provider. So it's something like Draw.io as well. They have their own application, but they also do a lot of blogging, and they basically explain these different types of UML diagrams, and they have tons and tons of examples. So I would highly recommend you guys to go through all these three. So for examples, refer to the blog. for the exact boxes, what is the significance of each boxes, each arrow types, each notation that we have seen in across all of these diagrams. So for that, I would refer you to the Unified Modeling Language Specifications 2.5. I think Wikipedia also has extensive documentation. The source doesn't really matter as long as it is referring to the UML language specifications 2.5. So there are tons and tons of sources. So please go through them. UML diagrams. So I would highly suggest going through that specifications and go through this blog. So if you want to see a lot of examples, real world examples meaning examples for real world software, then go to this blog. They have tons and tons of examples which you can refer to, or you can just Google it. I mean, just put in a use case diagram and just search for its examples and you'll get tons and tons of examples. And if you want to get a more in-depth idea about UML diagrams, there is this book by Martin Fowler called UML Distilled.
Now that we have come till the end of the session, please subscribe to our channel and hit the bell icon for more updates from Intellipaat.
Just a quick info, guys. Intellipaat provides PG certification in Business Analysis and Product Management by ENICT Academy MNIT Jaipur. The course link of which is given in the description below.